Thank you for viewing the Embedded Accessibility Strategy presentation developed by the MAISA Mathematics Leadership Team. This presentation is designed to help teachers, in particular those of students that receive Title I services, notice and make use of the accessibility strategies that have been embedded throughout the MAISA CCSSI mathematics curriculum materials to support student learning. The purpose of Title I is to ensure that all children have a fair, equal, and significant opportunity to obtain a high-quality education and reach at a minimum proficiency. While the strategies we will point to in this presentation can be useful for all teachers, they are critical to those who work with students that struggle in one or more areas of mathematics. Unit abstracts and graphic organizers in several grades have been updated to make more visible to teachers the mathematical progressions across grades. These updates are particularly helpful to teachers of students that receive Title I services as they articulate what learning opportunities students should have had in previous grades with respect to a particular topic. By making potential mathematical connections more visible to teachers, they are better equipped to help students make these mathematical connections a strategy to support deeper learning and retention.
As you read the unit overview, it is important to pay attention to how key mathematical ideas develop across grades. For example, one place to look is in the graphic organizer. The development of ideas can also be seen in the unit abstracts. In this 7th grade abstract, experiences students have had with statistics in previous grades are brought forth. In addition to making visible connections within and across grades, using the graphic organizer and abstracts, we have embedded accessibility strategies into the highlight lessons and formative assessments. At this point, we will begin to address the embedded strategies in these materials. We use the representation stars as a framework to inform updates to these curriculum materials. You will hear us reference the use of multiple representations in the upcoming slides as we draw attention to the embedded accessibility strategies. These graphics depict ways in which students engage with and represent mathematical ideas. The star on the right is designed to depict algebraic thinking, while the other is more general in nature. In the highlight lessons, students often have opportunities to represent their mathematical thinking in ways that make sense to them. Teachers can use students' representations to facilitate access to the mathematics and, eventually, as a strategy to advance students' thinking. So while these stars are not to indicate that students should represent a problem in 5 different ways all of the time, they do allow a way for students to, or suggest a way for students to access the mathematics in a variety of ways, allowing them to make connections among the representations and allowing teachers to prompt students to a higher depth of knowledge, potentially with deeper understanding. Here you can see the accessibility strategies we are going to discuss in more detail throughout the rest of this presentation. The use of technology, connecting to prior knowledge, launching with attention to key ideas, multiple entry points, intentional use of color, and the utilization of student thinking. In this grade 7 lesson, the task allows students to use technology to both visualize and explore interior angles of polygons. This app that you are about to see was developed by the National Council of Teachers of Mathematics and is available for free on their website. Please note, many apps from a variety of developers have been included in the resource section of the unit overviews. This is an example of an app that has been featured in one of the highlight lessons. Students begin their exploration within this applet with a triangle. As students use the app to move any vertex, they observe a dynamic chart displaying corresponding measures of the interior angles and their sums. Students will observe that while the measures of the angles change, the sums do not. Similar observations are made with quadrilaterals. For both of these polygons, clicking on the blue rectangle in the lower right corner reveals an informal visual proof. Note the use of color to denote the individual angles. The angle relations illustrated with these visual proofs can serve as tools that students can draw upon in problem solving later in the task. Engaging with online apps, such as this one, is another way in which teachers can help students make sense of mathematical ideas. The dynamic nature inherent in many apps can help students learn to reason mathematically and build their understanding of potentially challenging concepts.
The lesson overview equips teachers by drawing their attention to where students have worked on related mathematical ideas in previous units or grades. In this highlight lesson, explicit connections are made between strategies and experience students had in elementary school that are relevant to their work with angles in middle school. We worked to make connections such as this one visible in these documents, as it can be challenging for teachers to connect to students' prior learning experiences if they are unfamiliar with the learning opportunities in previous grades. When teachers are aware of these kind of mathematical connections across grades, they can help their students notice and be able to use them in their learning. The launch portion of the highlight lesson was enhanced by proposing questions a teacher could ask to help students access their prior knowledge relevant to exploring the task. Here, the teacher invites students to draw a parallelogram and decompose it into triangles. The highlight lesson suggests that there are multiple ways to show this decomposition, thus maintaining both the cognitive demand and multiple entry points of the task. The highlight lesson also suggests giving students an opportunity to clarify key mathematical ideas required in the task. Formulating dialogue that allows students to clarify their thinking around these key ideas before the exploration helps to ensure that students understand what the task is asking them to do, make sense of, and produce. Doing this enables students to focus on making meaning rather than guessing which ideas they are supposed to take away from the lesson. The student handout can also assist students as they explore. In this example, the handout is structured to promote accessibility and mathematical connections. As the notes in the highlight lesson suggests, there are many different ways that students can decompose the polygons into triangles. The diversity of decomposition methods increase opportunities for students to use a variety of angle relations as they engage in problem solving. In addition, the recording sheet is organized so that students can make connections between their sketch, the number of sides in the polygon, the number of triangles polygons decomposed into, and numerical expressions for the sum of the interior angles. The organization also creates opportunities for students to see patterns in reasoning from one polygon to the next and move to generalization. To help students move to generalization, the lesson overview suggests the use of color. Color is often used for aesthetic purposes in many classroom situations. However, the intentional use of color in problem solving has potential to increase students' access to key mathematical ideas. In this example, once the hexagon was decomposed into triangles, the interior angles of the polygon were highlighted in green. The angles highlighted in red were extra angles that needed to be subtracted from the total angle measures. Students use what they learned from the applet's visual proofs to subtract the appropriate amounts. Notice that color has two purposes here. First, it distinguishes the angles that are relevant to the sum of interior angles from those that are not. And second, it makes a visual connection between the pictures and the numerical expressions.
Units incorporate examples of potential student thinking intended to be used by teachers to open up students' access to the mathematical ideas, as well as deepen, clarify, or extend student understanding. To this end, we have tried to include representations and ways of thinking that teachers may be less familiar with given their resources and past learning opportunities. Examples of student thinking appear throughout the materials and are often apparent in the formative assessment tasks. Formative assessment tasks are rich tasks that allow teachers insight into students' understanding. For example, in this geometry task, teachers can analyze how well their students are able to use precise geometric language, definitions, coordinates, constructions, and logical reasoning. The sample student work provided and the assessment overview suggest common misconceptions, incomplete understandings, and/or strategic solution strategies that a teacher might look for in her own students' thinking. Further, a teacher might choose to use this work and accompanying focus questions to re-engage students in the mathematics. On the following two slides, you will see sample student work that could be used in this manner. This sample work provides an opportunity for students to consider the strategic use of tools. In particular, this student, student B, uses tracing paper to find the midpoint of each segment. The resulting folds, perpendicular bisectors, are intentionally highlighted with different colors and textures for discussion purposes. The student also uses a ruler to measure the distance from the endpoints of a segment to points on the perpendicular bisector. She informally and inductively reasons that points on the perpendicular bisector of a segment are equidistant to the segment's endpoint. In this example, student C uses the definition of circles to engage in solving this problem. Both compasses and geometric software are helpful tools in this approach. This particular approach is also productive to use with students as it illustrates the efficiencies with geometric constructions. Teachers might opt to include sample student work from the materials to prompt their students' thinking. In both of these cases that you just saw, teachers could ask their students to analyze and critique the sample strategy. In this video, we have outlined a variety of accessibility strategies that have been embedded in the MAISA CCSSI mathematics materials. In drawing attention to these strategies, we hope that we have helped you to notice and be able to use them as you enact portions of these materials in your classroom. Secondly, we hope that you can begin to incorporate these strategies as you plan for and enact lessons using your own instructional materials and textbooks. As we said at the beginning of the presentation, while the accessibility strategies embedded in the units can be useful for all teachers, they are particularly critical to those who work with students that struggle in one or more areas of mathematics. So in closing, the purpose of Title I is to ensure that all children have a fair, equal, and significant opportunity to obtain a high-quality education and reach, at minimum, proficiency. Using the accessibility strategies made visible in this presentation and embedded throughout the MAISA materials is just one way to help us achieve this important purpose.